The distributive property is another way of writing equations and expressions so that we can better understand multiplication and solve expressions later on as we advance through math. So right here on the screen, we have 5 tiles by 8 tiles to build a 5 by 8 array. So we could write, the first expression we could write is that it's 5 times 8. Remember, we can use the multiplication symbol that we're used to as an x, but we also learned that we can write it now as a dot, 5 times 8, because that means the same thing as multiplication. With the distributive property, I now know that I can break things apart to create multiple expressions. So for example, let's say I want to keep the 5 tiles going down the same, but I want to break it apart. I could take these 2 rows of 5 and separate it. Now if you look, I have a 5 by 2 and a 5 by 8. So if I wanted to write it in expanded form, I could say I have 5 times 2, which I know is 10, plus, on this side, I have 5, and instead of by 8, I now have 1, 2, 3, 4, 5, 6. Which is 30. So if I put those together, 5 times 2 is 10, and 5 times 6 is 30, I'll still get the same exact answer as 5 times 8, which is 40. That's not the only way I can do it. There's many other ways. So say instead of taking the 2 rows of 5 this time, I want to take 3 rows of 5. That would give me a 5 by 3 array and a 5 by 5 array. So I could write it in expanded form as 5 times 3, which is 15, plus I'd have to add on my other array to get back to my total and do 5 times 5. Again, I haven't changed my number of tiles. I'm still working with the original 40 tiles. I'm just writing it in different ways by breaking it into 2 groups and then adding them both together. I could keep going. I could also write this by making 5 groups of 4. So then again, I'd have an expanded form a 5 by 4 array, which would give me 20, plus another 5 by 4 array. So the 20 plus 20 would get me back again to my original 40. So notice all of these expanded expressions, all of them, when I solve them using order of operations, if I multiply and then add, I will always get the same answer of 40. And again, we call these our expanded expressions. You can write them another way, and the way we call those are factored expressions. Notice these are expressions because they don't have an equal sign. So if we want to write them as factored expressions, we're going to say, what do both sides of the expression have in common? So I'm looking at 5 times 2 plus 5 times 6, and I'm noticing that both of them have a 5. So when I say common factor, they both have a common factor of 5. So I'm going to leave that outside the parentheses because I know I'm multiplying both numbers by 5. And then inside the parentheses, I'll write my 2 plus my 6. And then close my parentheses. Again, when the number is right next to the parentheses, you know you're multiplying. If you think about order of operations again, 2 plus 6 gives me 8, so I'm back to 5 times 8. I could do the same thing with the other, 5 times 3 plus 5 times 5. I have a common factor of 5, so I can factor that out and put that on the outside. And then inside the parentheses, I'll use my 3 plus my 5. once again, if I used my order of operations, I would say 3 plus 5 is 8 times 5 is 40. So I still get back to the same number of tiles I started with. And the last one, my common factor again is 5. And then inside, I would say 4 plus 4. Either way, I'm still going to get back to my original number of tiles, which was 40. I'm just breaking them apart differently each time. So expanded form shows each array as I built them. So when I built, for example, the 5 by 4 and the 5 by 4 and adding them together, the factored form shows that I can really, in parentheses, add the 4 plus 4 first and then multiply it by 5. I can take that same array and then keep the 8 intact, but then split up that 5. So for example, I could keep 2 rows of 8 and bring those down. So now, if I'm talking about my expanded form, I could say I have 8 times 2 plus 8 times, and up here, I now have 3. I could also do the same thing by moving down another row. Here, I would have 8 times 3 and 8 times 2. So if you look, it would be the same expression. If I wanted to put that in factored form, try and do that on your own quickly. Think about what it would be. So hopefully you were thinking about your common factor was 8. So the 8 goes outside the parentheses. And then inside, you would be adding your 2 plus your 3. And again, that was my 2 rows of 8 and then my 3 rows of 8 to give me expanded form and then factored form. When you're dealing with an open array instead of the tiles, you can use the 4 by 6. So I know it's 4 rows of 6 in each row. It's the same exact thing, except you have to visualize where you would want to break it instead. So my original equation would just be 4 times 6. Say I know I want to keep the 4 together, but I want to break apart that 6. Well, I could say to myself, I could split the 6 into a 2 and a 4. So now one of my open arrays would be a 4 by 2, and the other open array would be a 4 by 4. So in expanded form, I could write it as 4 times 2, because that's one of my arrays, plus 4 times 4, because that's my other array. If you were to check it, 4 times 2 is 8, and 4 times 4 is 16, and if you add that together, you're going to get back to your original answer of 24. To put that in factored form, I would then look for the common factor, which is 4, and write the 4 outside the parentheses, and then inside the parentheses, I would have the 2 plus the 4, showing how I broke apart my open array. There's other ways I can do it. I also could say that I want to make a 4 by 3 and a 4 by 3. So then in expanded form, I would write 4 times 3, plus 4 times 3. And then for factored form, the common factor is 4, and inside I would put 3 plus 3.